Hey guys, this is the last video for this chapter. So let's take a look at finding the volume of composite figures. So if you remember, last chapter we found the area of composite figures. Now we're going to do the volume. So recall that composite figures are made up of simple shapes. Three-dimensional composite figures are comprised of various solids, including all the ones we found the volume of, guys. So cylinders, spheres, all the different type of prisms that we've done, pyramids, and cones. So everything that we have found the volume of so far, we could put together and make composite figures. To find the volume of a composite figure, find the volume of the smaller solids and add or subtract them. So same as finding the area of composite figures. So we have to figure out whether we're going to be adding or subtracting two values together or not. So let's take a look at number one. Zoom in a little bit so we can see a little bit more what's going on. So take a look there. Hopefully you guys can see that we have a rectangular prism and we have a triangular prism. So I'm going to focus on that triangular one first. Here is the triangle base, and the other one is back there. So we're going to need to find the volume of the triangular prism. And we're going to need to find the volume of the rectangular prism. So we can draw the base here and here. So, since I have the pink in my hand, we're going to stick with that one for a second. The volume of a rectangular prism, we need the area of the base times the height. Well, the base is that pink figure that I colored, and since it's a rectangle, area of the base is just 5 times 12, which means we get the area of the base to be 60. So the volume of that prism is going to be 60 times, we need the height of the prism. Remember, the height is the distance between the two bases. So in this case, it's that 10. So that volume, nice and easy, is 600 inches cubed. Now we need to find the volume of the rectangular prism. Now this is where it might be a little weird. We have to recognize that since this is a rectangular prism, that makes this portion 12 inches because it's the same as this base over here, which means this one is also 12 inches. So I'm going to draw our base right here. We just decided that that was 12, and the height here is the same as the height of this prism, which is 10. So we need the volume to be area of the base times the height. The base is a triangle, so 1/2 base times height, which means 1/2 of 10 times 12. So we get that area to be 60. And then, oops, you guys can't see, sorry. Then we need to plug that into here. So volume is going to be 60. And we need the height of the prism. So if we look at our picture again, the height has to be the distance between our two bases. So in this case, the distance between those two bases is right there. That's the 5 inches. It's the same as this one up here. Okay. So 60 times 5. We get our volume then to be 300 inches cubed. And the total volume then is going to be 600 plus 300. So we get 900 inches cubed. We can go up here and put that on our line. So 900 inches cubed. Again, don't forget your units. You guys know how important those are. Let's take a look at another one. So that one, we took two figures and we had to add their volumes together. This one, although it is a little hard to see, this is a prism and it's got a hole drilled through it. So this lighter gray area is actually empty. So we're going to have to find the volume of the prism. and we're going to have to subtract the volume of that cylinder that's inside. Alright, so let's take a look at that. The prism, we're going to need the area of the base times the height. They give us the height of the base right here, it's 25, and the base is actually 25 as well. So the area of the base is 25 times 25. And so we get that to be 625. And then the height of our prism, the distance between the two bases, that's the 30. So 625 is the base, the height of it is 30. So we get our volume of our prism to be 750 centimeters cubed. And then we're going to need to find the volume of the cylinder. So volume of a cylinder we know is pi r squared h. There's no 1/3 here, it's not coming to a point, right? So we don't need the 1/3. We have to look at that picture then and see if we can figure out what the radius and the height are. This 8 centimeters right here is pointing at the diameter of our circle, which means that our radius is 4. And the height, it goes the whole distance of our prism, so the height is the same as the height for the prism, it's 30. So if you put that into your calculator and simplify, we get 480 pi centimeters cubed. And on this one, like I said, we're taking the prism and we're drilling out a hole here, so we're taking the cylinder out. So our answer is going to be 18,750 minus that 480 pi. Don't plug that into your calculator and get a decimal until the very end. So just like all of our other stuff that we've been doing, don't round until the end. But if you put that in your calculator and then we're rounding to the nearest tenth, you will get an answer of 17,242.0 and then centimeters cubed. Hopefully you guys are plugging that stuff into the calculator and making sure I don't make a mistake, because we know it wouldn't be the first time. So please plug those in and check, and if any of them are wrong, we can talk about them tomorrow. Let's look at number 3. Number 3 is another one that's a little hard to see, but this one is this rectangular prism, and there's a cone that's drilled out of the center. So just like in the last one, we are going to be subtracting. So we're going to do the volume of the prism, and we're going to subtract the volume of the cone in order to get our final answer there. Alright, so let's go down below and find the volume of the prism first, because I think that'll be the easier one to find. So the prism, we need the area of the base times the height. Well, the base is this square right here, which means the base is just 20 times 20. So 400. And then the height of our prism, oh, we don't know that. So we are going to have to figure that out first. So, I apologize. Let's draw our cone really quick. I forgot we need that first. My bad. So there's our cone. It tells us that the diameter is 18, which means that the radius is 9. And it tells us that this slant height here is 15. So if we draw in that height there, that yellow height is perpendicular, and we need to find it. So I'm going to draw that triangle a little bit easier for us to see. We have a 9, a 15, and the H. The H is going to be the height of our prism and the height of our cone. So we luck out that doing Pythagorean theorem just once gets us the answer we want. So 15 squared equals h squared plus 9 squared, and you'll get to h equals 12. Cool. Sorry about that. I forgot we had to do that first. My bad. Let's go back to the volume of our prism. So volume of our prism, we need the area of the base, that's the 400, times the height that we just found, so that's the 12. So the volume of our prism is going to be 4,800 meters cubed. And then we need the volume of our cone. Which we know is 1/3 pi r squared h. And here's our cone up here. We already decided the radius was 9 and the height right there is the 12 that we found. So we can just plug everything in nice and easy. 1/3 pi 9 squared times 12. And if you plug that in your calculator and simplify, you get it down to 324 pi meters cubed. So we have the volume of our prism here, we have the volume of our cone here, and although our picture is a little hard to see, we can guess that we're going to have to subtract those two, so that's why we wrote this here. So the prism we got to be 4,800, and then the cone we got to be 324 pi. And now we can go ahead, put that in our calculators, and get a number. So we get it to be 3,782.1, there's the decimal point, Miss J, meters cubed. Alright, we have one more that we're going to do. Alright guys, so we've done 3 so far. 1 addition, 2 subtraction. So take a look at number 4, and hopefully you guys can see that that one is going to be addition as well. So we have a cube on the bottom here, because this right here is a square, 12 by 12, and the height of it is also 12. So we're going to find the volume of a cube. And then right here we have a square pyramid. So we're going to add the volume of a pyramid. Alright, let's do the cube first because that's nice and easy, right? The cube is the volume is equal to the area of the base times the height. Base is 12 times 12, which means we get the base to be 144. So the volume is 144 times 12, which means that volume is 1,728 centimeters cubed. And then we need the volume of that square pyramid. And we know it's a square pyramid because the base is a square. But since it's a pyramid, we need that 1/3. So 1/3 the area of the base times the height. So base, we look out, it's going to be the same as the cube, so 144. And then the height, if we look at our picture, they gave it to us. We don't even have to solve for it. It's just 18, which means this volume is 1/3, 144 times 18. If you plug that into your calculator, we get 864 centimeters cubed. Oops, you guys can't really see. Sorry. Now we just have to add them together. The cube and the pyramid together, it kind of looks like a house, right? So we can add the two of them together. 1728 plus 864. And again, I hope you guys are checking my calculations because we know that sometimes I can be wrong. So please, please, please make sure you're plugging these in on your own and making sure that they work. But we should get 2,592 centimeters cubed. Alright, make sure you've got units on all of your stuff. Make sure that you're drawing pictures of the base if you're still having trouble finding the area of the base. But we can talk about any of these tomorrow that you want to do. We are going to practice tons of composite figures and make sure that you guys are all set. And then don't forget you have a test coming up on Monday. So we need to make sure that any questions you guys have we get answered. Alright, I'll see you in class. Bye.